Happy Tuesday. Good morning. How are we doing? Good morning, Xenocron. Let's see, I just got your note. Saw your message. Code coverage. I was watching John Who's channel today. Very nice stream on. Let's just go find it. It's on YouTube. Setting up CI and properly testing your Rust crate. 2 hours, 46 minutes of awesomeness. It's very, very cool. And this was one of the pieces I saw from it. I thought, you know what, that would be fun to play with. Eventually. Yeah. Yesterday I was a little under the weather. Today I'm feeling much better. Thank you. How are you? You indulged in even more functional goodness today? Oh, yesterday? What more functional goodness could there be? Oh, interesting. I'll pour some tea. Let's see. Programmable configuration language. Okay. Huh. Fearlessly refactor. Lies. This is pretty cool. A little bit of coffee left in my mug. I gotta. That's coffee ginger tea. Well, that's interesting. Oh, this looks gross though. You have to escape to... Oh, the slash is the ASCII substitution for a lambda? Oh, interesting. Because it looks like it's just escaping the first character. Huh. I see. I mean, it does seem rather convenient. Types. Interesting. I'm looking at it thinking, what configs do I have at work that I could play with? Maybe some Kubernetes. Ooh, Docker. Interesting. What does that do? Ooh. Is it better? I don't know that people would find this better. This is fairly readable. This isn't. I mean, you probably get more checks here, right? Like you get the compiler, you get as a lambda, it's better. Oh, it's funny. I mean, arguably, you get a compiler in this case. We know that compilers make your life just lovely, right? But I doubt it's going to be able to validate things like this, right? Which is what a lot of Docker is going to be. This is interesting. Complete example. So this is nice in that you get to define some options. It does make some nice files, though. My friend Palumi has entered the chat. Okay, what else? I want Terraform. Where's Terraform? Is that cloud formation? What is this? Hmm. Interesting. I do like the diffing. I like the strong typing. I gotta take my boots off. It rained yesterday. It's gross out. You go from like lots of snow on the ground to slush, frozen puddles. My trip to the office was a harrowing experience this morning. See, I like it a little better outside when the trees have that little dusting of snow on them. We're at the point where the trees have shed their snow. All right, there goes the coffee team. Got a nice ginger tea this morning. All right. Well, it's interesting. February 1st, okay. Somewhat updated. Wow. Somebody's using source hut in the wild. There's nicks, a bunch of different pieces here. So what's with the languages? Is that just so that you can produce the configurations in other languages other than this? Other than the doll language? So you produce some sort of configuration. And that's what doll does by default. So... okay, she'll not... oh, I see. Oh. Fascinating. Well, it looks interesting. All right. Oh, shoot. Why did I start streaming today? I forgot we had this to look at. Kidding. Oh, that's right. We ended up hitting that. You gonna go cry? Okay, no. There's a catch. Okay. Hey, Mouse X, how you doing? Trying to charge my phone. Okay, put my T's in the way. All right. Yep. Async functions and traits. And we are looking at this here. Limitations. There's a catch. If you try to spawn from a generic function like printall, and like the majority of async users, you use a work-stealing executor that requires spawn tasks to be sent, you'll hit an error, which is not easily resolved. Ooh, I didn't see the little 2. Oh, actual error is more noisy. Got it. Thank you. Yeah, I'm doing all right. Yeah. You guys have a good weekend? I was a little under this weekend. Feeling better. Okay, so in this case, we're inside of... I thought we were supposed to be inside of an async function. Oh, we're like inside of spawn print all. So we spawn, we have an async move. Future cannot be sent safely between threads. Spawning from generics. So I is an async iterator. That is send in static. I implements display. Okay, where are we using count here? Count here. You can see that we add an I send bound, the function signature. But that was not enough. To satisfy this error, we need to say that the future returned by next is send. Ooh. I say, yes. But as we saw at the beginning of the post, async functions return anonymous types. There's no way to express the bounds on those types. There is a potential solution. For now, there's a couple of things you can do to get out of a situation like this. Hypothesis. It's uncommon. So it's because the future returned by next is not send. It's, what do they call it? Anonymous types. Is that what's happening with us? Let's double check. Impl future output, yes, cannot be sent safely between threads. So I'm guessing it's the same. You cannot express any bound on impl foo. Hey Toss, good morning. Happy Tuesday. And welcome. Okay. First, you may be surprised to find that this situation just doesn't occur all that often in practice. It happened to be the first time we ever tried this. Well, it is the same. Cool. Async function, syntax of sugar, returns impl future. Right, and we saw that up here. Okay. I've seen the discussion in an audiophile forum where they argued that memcopy made their music sound worse. What? Okay. How's it going in the land of Brown and Rust? Pretty good. Pretty good. We're enjoying ourselves. Part of this stream is just playing with new crates, kind of getting outside of our comfort zone, and I think we landed square in that. Was there some delay? How can... What? What? But but how does something that doesn't change the data produce a hard edge? Well then, well, new is the C++ method and it sounds better. But new is a wrapper around malloc. Wow. Wow. This must be quite an exciting thread here. I'm guessing that I'm hoping that somebody goes into what new is calling and that memcopy doesn't actually change data, so it can't. Yeah. All right. It got linked in Hacker News? Oh, funny. Fun. Oh, wow. Oh, yeah, it is a 10-year anniversary for this thread. That's amazing. Oh, it's a well-known joke. That's funny. That's funny. Sure. Okay, I didn't read the rest of this. Playing a WAV file from RAM disk gave the best sound. All right. Okay, so I mean, people on the internet, you never know, right? Somebody could absolutely be, or think that's the case. Or maybe they're on some Linux machine where there's some awkward delay for that. But I mean, malloc versus new shouldn't be. They're basically the same thing. Well, we wanted to capture a name that kind of said, hey, this is built with Rust, and we were enjoying coffee at the time. It was one of those streams. But yeah, could be or the tale of, you know, adventure finding the perfect brew. Could be. We should say that from now on. All right. Yeah, that's great. All right. First of all, you may be surprised to find this situation just doesn't occur all that often in practice. I am disappointed in myself then. Or maybe we're just a special snowflake. I don't know. For example, we can spawn a task that involves the above println function without any problem. This works without any send bound whatsoever. This works because do something, where is do something? Here, knows the concrete type of our iterator, countdown. Oh, okay. The compiler knows that this type is send and that println iter therefore produces a feature that is send. One hypothesis is that while people will hit this problem, they will encounter relatively infrequently because most of the time spawn will be called in code that is generic over a trait with async functions. We'd like to start gathering data on people's actual experience with this. If you have relevant experience here, please share, please comment on this issue. Interesting. Do we need send bounds to stabilize async function and traits? Lungo's lair. Oh, I like the alliteration. Ah, yes. Got the long pole with the lungo. Beautiful. That makes me want coffee. Okay, so not a contribution. Okay. We got down here at the bottom. All right, let's see if we can work around this for a moment. So, what are they saying here? Is it... Which await is it? Is it this one? Is it this async block? Is it this one? All right, let's look at the command line version of this. Ah, okay, so it is pointing at our async moves. So if we get rid of that, it's possible. And this is because of the either from futures util. How many levels of indentation are allowed? Oh goodness. I I I don't care. I was going to use more strongly colorful words there, but as long as it can get on the screen, we're okay. To me, there's a difference between like getting mud on the wall code, right, and then having like kind of production quality code, which, you know, often the mud on the wall becomes production quality code, but that's okay. Later, as you come through and you're refactoring things, you clean it up, you make it nicer. In this case, yeah, moving this out could very well, right? This section here would probably get moved to its own function. See text.io, I haven't heard of that one. Yeah, we'll get the error up there. All right, Diablo. Well, thanks for popping in. Happy Tuesday. There we go. Yep. That's my preference on indentation. If it fits on the screen, we're good. Yeah. For me, it's more about readability. If it starts going off to the right or word wrapping or something like that, you know, then that it's funny. Like I like the 80 character bounds on this, but with all the wide monitors and stuff, I'll say, hey, we can get up to 120 characters before we start to wrap. Right, 120 is also good. I don't even know how many characters we allow on this screen here. Let's see. Oh, I see. That's 80. Let's see, 98, 99, 100. So that's 100. Or now we're at 100. Okay. So, yeah. Oops. $400 character lines. I do see programming as kind of thoughts and ideas. So having them all in one line doesn't work very well. It should read like a book. Yeah. All right. Oh, where are we going to get this? Cargo check. Oh, how do we do this again? We need 2 and 1. Is that it? I don't remember. It's empty. Damn it. Oh, is it in about 1? Ha. Okay, now we're going to ctext.io. Huh. Fancy. All right, yeah, there's some warnings in here. We could probably get rid of those. These can also go. That doesn't seem like it's the whole of it. Did I just get rid of too much? Message, no. expire? There we go. Right there. It's not unpin? What? Okay. Wait. There it is, right there. It's not unpin. Oh, unpin is not implemented for that. Oh. You're right. On 53. Why? Wait. This is a different error message. What? This was not the same. This is not the same error message. What changed? Oh, I undid too much. I did box new, box pin. Okay. No, that's okay. There we go. Okay. Let's try again. Okay, so coming back here, so what it's saying is that this async block here is not send. Why? Question mark operator can only be a what? Oh, let's remove error and 1. Okay. Wait, were we supposed to await that? No. It's pinned, though. So it's complaining about this piece now. The question mark there. Skadooby, how you doing? Happy Tuesday. To be a feature that resolves to pin bucket. Expected that to be a feature that resolves to this, but it resolves to result something else. Oh, is that because We were just inspecting the error. We were not doing anything extra to the error. It looks like it's gone a little further, that our inspection of this. Oh, by awaiting it here. Ew. Really, it should have been awaited. Okay. Okay, good. We're back to the same thing. And if we remove our enum, either left and either right, it's not going to work very well. We could just use the fallback on fallback and not use the type matching here. Because, so their suggestion was what? Basically, let the compiler know what the type is by putting it into a local before the call to spawn. If it's boxed, then we don't need the either, right? Oh, still mismatched types. Just do box as a debug measure. Oh, I see. Now, would you box the whole thing? I don't think I have that in. There we go. Okay. Is it the message receiver? Let's go look. Hey, that's our trait, isn't it? Let's see, where is message receiver defined? Clone it a bunch. Here's message receiver. Yeah, that's our trait. So technically it is the message receiver because this returns something that's what impl future output equals that. So it's not a concrete type. But how can we get this to know the type? We would have to receive ahead of where here. So we could do that, right? We could do this. Oh, here. What if you do impl as an associate? Impl as an trait associated type? What do you mean? So design it like the future thing in tower. What's that the associated type to impl future? Which part though? Hold on, I want to see what this, if this gives us the same error. Because at this point, yeah, it's the same thing. I'm suspecting that it's actually the enums. Do we even need the async move now? We can just put the handler.await in there. Oh, but now it's not returning a feature, but that might be okay, actually. Actually, if it's not, if we just return the handler. Handler is something that impulse future here. Future is not send, okay. Either, yes. Now this one's talking about the boxed one. The wait occurs here. The value may be used later. The value could be dropped here. So in this case, handler's a future. It gets saved in either left, either right. We basically have a no op, right? Just to make this compile, needed something like this there. Isn't there... Oh, I don't think that it'll let us do this. Right, because it does the desugaring thing, but it won't let us write this directly, will it? Use a similar construct with the tower service trade on Nightly a few months ago. Oh, okay. Okay, I didn't understand that you could actually do that there. Well, let's try it. Okay. Now, just before we go down that road, though, it looks like it's not actually pointing to the same place again. So it's saying this has type. Okay. Value is later dropped here. Oh, I see it. They heard one note above, but it's still the send constraint. All right. And just one moment. So in this case, I can actually move that down here. Okay. Oops. Okay. Does that need to be pinned though? No, not anymore. Okay. Okay, it's still the same. Good. Let's go to a message listener. No, message receiver. Before the handler was non-send in the inner async block. So you had that error. Now you lift the async block to the whole either call. So it says that either is not send because either generic type. Oh, I see what you're saying. Yep. But I can't afford a box. Wow. Wow. All right, so and we're in web lib. Do we need return position infiltrate in trait? Do we still need this one? Let's see. No. Okay. All right. Let's, oh, interesting. You can put a lifetime here. Plus A, where self is of lifetime A. I see. So for the lifetime of A on that future. Wow. That's cool. Oh, I guess that's not quite the output, is it? It's more the future. No, I want, future from trait. What? Okay. Whatever. So we remove that. We put future over here. Oh, that's fine. So we need the lifetime. So we need A here. Can we use of undeclared lifetime A? Do we need that here then? First declared here. Oh, it's here. And the elite lifetime should be wrong. Oh, should be fine. Okay. Future from trait. What is this? Oh, this is pointing to where we're implementing this. Okay. History.
Gotcha. That freaking medic's a spy.
Self future. Okay. Associated type of impulse without body. Yes. Oh, interesting. And our type here, we don't. Impulse future. Wait, you can just say impulse future here? Whoa. What? You can let it fill it out? No way. that is unreal. Wow. Oops. Come on, fingers. Okay, now we need to return async block, yes. Oh, async move. I do that all the time. Okay, missing generics for that. It'll leave the lifetime. War clause not allowed here. See issue, blah, 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 blah. I would like to, but I can't. Move it to the end of the type declaration. That's where it was. Oh, it was there. Wasn't it? Time, future, future. Oh, can it not be here? But wait. Oh, I need a where as well. Okay, fine. Got that. Missing generics. All right. We got it. Okay. That makes sense. So, okay, just to review. Now, when we have a where here, it ends up going after the right-hand side in the impl. That makes sense. I get that. Okay. All right, let's do the next one. Okay. And here we are. Cannot move out of self because it is borrowed. Okay, that's a different error. Cannot return the cannot return value referencing local data. Ah, sure. We could just make it not local. Is that? Wait. That's still local? Okay.
And I was like, that's cool.
Honestly, if they also release impl as trait alias together with async function trait, then it's 100% fine because you can work around limitations like that. Interesting. New error unlocked. Let's see. Cargo check. Await data. Oh, I'm not awaiting enough because here I should have awaited that. Okay. Wait, is this the same error as before? R cannot move safely between threads. Huh. I need an R sync bound, apparently. Okay, where is R? Here? Yep. Okay. Cannot move out of self because it is borrowed. What is borrowed? Oh, self here. Oh, okay. Hey, we can handle that. Nope. Come on, paste there. That's not what I wanted, but we'll take it. Well, it was complaining about send earlier, not sync. Hey, Jonah Sync. This is a crate called Bastion. We're using a crate called Bastion. And yes, it is very Erlangish, which is part of why we're using it. Okay. Still okay. Let's clean that up. Hey! There we go. Let's run it. Does anybody remember why we were doing that? Now that we've successfully worked around nightly pain with entirely too many associated types and gats, we can move on. Yes. Okay, so I am a little curious here. That whole thing with nightly. Let's go back to that type. So by using this with an impl future on the implementer side, we can avoid an allocation. That's the lifetime stuff is unstable here, right? It's really just the impl future bits, yeah. Wow, okay. Otherwise we would have had to allocate there, which, you know, if we were in any other kind of, yeah, whatever language, it would have been allocated anyways. Wow. Well, that's neat. Okay. So before we were using async trait, right? Now we're not using async trait anymore. And async trait, it basically, what, does type erasure with boxing and then works around it with the macro generation. Right, so it's gonna box it regardless. So we save on a boxing there, which is interesting. It's good. Ooh, story time. All right, I'm gonna get my tea. You're so frustrated and banging your head against the wall. You just wrote Impel Future in the associated type and was as a meme. And then Ropes was like, "This is an unstable future, you dummy. Feature, you dummy." Yeah, oh, that's great. Oh, that's fantastic. All right, so this is since 2018. Allow type aliases and associated types to use infiltrate. Replacing the prototype existential type. This way to declare type aliases and okay. I didn't even know about existential types. Interesting. Is existential type stable? Oh, I see. It's not. Okay. My preferred, whenever I go to like an RFC, I want to see the status. Like the first thing I ever look for is status. Like companies do that too, right? You'll write like a document describing, you know, some architecture or something, and then years later somebody else comes to it. Like, is this the current thing? What's the status of this? Did it actually get implemented? I'll be like, Alice helped me a lot when I was learning futures, back when they first came out. She was very, very helpful. Alice helped me understand that with generic types in Rust, it's the caller that basically gets to define the type, and that you can't you can't have the return value define the type of, you know, the curly or the angle bracket, blah blah blah. I remember that well. So thank you, Alice. The name existential. Oh, this comes from the fact that when you type infiltrate, you are saying there exists a concrete type that goes here. This is as opposed to generics where you say all types that implement this trait can go here. Having this pair of concepts with one meaning, all of them, and the other meaning, there is at least one of them. It's really common in mathematics. That is interesting. Yeah, that's a good definition. Okay. I wouldn't know how to explain that concept, really. For me, a bunch of math theory is like monads. I know what they are, but I can't explain them. Yeah. Yeah, what is that other quote? I'm sorry, I wrote you a long letter. I didn't have time to write you a short one. Forget who that's attributed to. But I get that a lot from Alice's explanations, right? They took the time, they had the understanding to be able to write this short letter. Happy Tuesday, Sharper guy. It's just a monoid in the category of endofunctors. Oh, goodness. All right, so back to where we were. We have... Oh, we got some stuff. Panicked. No distributor welcome service. Oh, interesting. It's actually being called. Huh. That's correct. We didn't wire that up. Okay. So in welcome we have... No, not web. Welcome. Don't care. Don't care. All right. So we need to start this. Let's go to server. We need to start the welcome service when? Before web. Oh. Oops. My multi-helix didn't work well. All right. A trait is just a traitoid in the category of endo traders. Oh, tricks of the trade. Oh, that's cool. I don't know where to find out about those things. Right, like somebody, you know, may have explained something or had a good presentation about these sorts of things. I see them occasionally in like This Week in Rust, that newsletter. Yeah. I would like to learn more about Rust by having the sort of curated kind of stream, right? It feels like there should just be a list of these things, right? These sorts of YouTube videos, websites, whatever, that kind of explain them in order of your learning in Rust. Like, you're here on your Rust adventure. You might enjoy this content. I think there's a... Oops. Let's go back. No. Did I close that? Server cargo. Because I can't leave that there. It's not alphabetic. Okay. Good, good. Let's try again. Should start up this time. Hey, look at that. Now, it was saying that we had one of these already open. There it is, connecting. Okay. So this setup's supposed to connect, right? Sometimes it takes like 10 to 15 seconds for some reason I don't understand yet. A whole personality test when you sign up for the service, so they can give you number 3 exercises for Rust intermediates interested in intermediates interest in multi-threading. Yes. Yes. Because I could say like, yeah, you know what, monoids right now, I'm not quite into that yet. I need to understand futures better. All right. Web message listener received unhandled message. Look at that. Lovely. Okay. Okay. What does this mean? Like, welcome server received message, blah, 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 blah. Okay, good. So welcome responded because code, say hello. And they sent this welcome message back to the person that sent. Rondev. new project idea, Tinder-like interface for learning Rust features. I don't even know what Tinder looks like. I mean, I've heard about like swipe left, swipe. I've been married for ever, more than half of my lifetime. I just swipe right or swipe left. Oh, okay, gotcha. Just can't 100% express monads since they are usually defined on trait levels, and if I recall correctly, the type system just isn't there. It's not. I actually am planning to learn monads because I've never done Haskell, and I've not really done monads to the point where I understand that they're monads. Maybe I've done them, I don't know, right? Because it's a pattern. Sometimes you just end up in one. But I look forward to them being supported in Rust so that I can learn them. Or you get what I'm saying. Okay, so in this case, welcome is being sent back to what? It was being sent back to whomever sent the message. Who sent the message? Was it history? I don't remember. Let's go look. And that listens. Okay. Da-da-da. It's not history. It must be prompt. Okay. So we message router connect. Oh, that's right. And we were using the typesafe pattern here. Cool. So we send this message. Fine. If you read the Haskell book, by the end you're like, oh, I get it. And then the next day you wake up and you don't get it anymore. Oh man. Okay, I think we're gonna have some other issues in here, but ignoring that for the moment. We send that, and we have a message receiver where here we're saying that the type of message we can receive is that. Oh, interesting. Huh. I wonder if I need to change my receiver occasionally. Because right now, we basically do this where we submit a handle, right? We have a receiver, we pass it our handle. And this is implemented, and we specify that our type is that. But what if we actually want to be able to switch types? Say, you know what? We're through the welcome phase. Now we're going to go on to the game phase or the login phase. And our message types need to change. Either that or all messages basically need to be the same. And message receiver, could we use GATs here instead of the associated trait type to be able to do this? So in one case, we would say impl this for message or welcome message, whatever it is. Right. And then we do this again for, let's say, message. Right. Because then we would have different impulse for this. Then we could have different functions, the receive being called based on the type of message that's associated with it? No. Hold on. For receiver. Okay, message receiver. I'm just going to play around with this for a moment. I'm going to copy paste it. Okay. Message receiver new. M for message, where M is standard format. Plus send. So if we did that, we basically get a different receive function for every type M. I don't think that's going to work because of how we have to call that function. I'm trying to make it Erlangish, right? I don't know if it's on accident or just because I like that style. Because here we would receive a type. But we couldn't have R here. That would have to be... This would be like R : Oh, it's not even an associated trait type, so we can't reference it. Okay. So we either move back to not using on tell, but using on fallback. What do I need to express? Great question. So let's go back to prompt. Throughout the lifetime of this component, it might receive different kinds of messages. One kind of message might be a welcome message, right? And so in this case, it's talking to a specific supervisor, right? Supervisor chain. And so it's sending messages to the welcome service, which might give it like the message of the day, right? And then after that, it'll need to start to talk to login or register. And while we could have one giant enum to rule them all, we could try to have them more specific, right? Have welcome versus login versus registration. And so I was thinking, like, maybe we have a different impl per, right? Here's welcome, here's the game. All right, because this could be like, you know, login. And in this case, to me, what it looks like is that really we need to take what we're receiving from Bastion just a little bit further. So instead of using on tell here, we use on fallback. Because in this case, we get this dine any, right? And I thought there was a way to figure out what the type here was. Actually, I don't know what they suggest here. Yeah, that's what I'm realizing slowly. Where's trying to tell? I want to see what they're doing here. Yeah, I don't know. I've never really done downcast ref. But it looks like they're doing that for me already. So in this case, they take a message. And what is this message.is? It feels like JavaScript, right? Exactly. Interesting. So it looks like they're doing it. Oh, I wanted on tell. So for each one of these, it goes through each one trying to see, oh, are you this type? Are you this type? Are you this type? Okay. Yeah, it's got to do it somehow, right? Oh, returns true if the inner type is the same as T. Oh, wow. Huh. What's the overhead on that? Using type ID? How does it know? Wow. How does it know the type? The whole Andy stuff reminds me of a job from an engineer, a quote from an engineer at a job interview you had. Dynamic dispatch is supported in Rust. Somewhat. Kinda. A bit. Oh, this is... It's interesting. Ooh, downcast unchecked. There we go. That reminds me of like C++, how you can basically truncate a vtable. Wonder if it does the same sort of thing. Right? Wait, downcast unchecked versus downcast unchecked. What is the difference here? Oh, one's on box. Okay, that's on box. It's fine. Wait, this one's on box. Impl A, box dine, any set. Oh, this one's sync. Fine. Huh. How does type ID work? Type ID represents a globally unique identifier for a type. It's opaque. It's currently only available for types which ascribe to static, meaning they're owned. This limitation may be removed in the future. Beware of relying on them in your code. Okay. Well, that's interesting. So Bastion is using the type information to be able to call the correct function. Got it. Are they doing it the right way? It might not be the way that I would do it. I guess they're optimizing for having few types. And so if we come back to goodness, wherever they handler, there it is. Okay, so they're relying on the fact that you will have few of these, right? So instead of looking it up in, let's say, a hash map and mapping the type of the handler to this, could they even do that? Could they say, oh, you know what? They can't. They can't know the type and get the type ID on the anything until... Wait, no, that's not true, is it? Because here they're doing try into tell. Ah, so they do have the type here for that. Of course, okay. But yeah, where would you put a hash map? You couldn't put a hash map anywhere. Unless this was all const. But Rust doesn't have compile time hash maps like C++ does. Like in C++, you could have kind of like a const lookup table using... Yeah, I think there's one in Boost, isn't there? The PFA. Oh, PFH crate. PHF. Okay. Perfect hash functions data structure. Interesting. Okay. So you could, but you'd probably need a macro for this. Fancy. Okay. Who uses this? Strum. Okay. All right. So I get what they're doing. Coming back to what we're trying to do. So we could do that ourselves and handle it later. Right. But then we don't need message handler. We're basically rewriting message handler. So we could get whatever this returns, right? What does this return? returns a signed message. What can we do with a signed message? Nope. Docs. Bastion. There it is. So we could get the signature? This is the only one? Yes, okay. The alignment pointer? Okay. Signature, we get a ref adder. That's who this returns a message signature to identify the message sender. Yeah, that's implemented for everything. Okay, so how are they using it? So they get a signed message, okay. Goes into the state, returns a message handler, and then, oh, that's right, on basically the unmatched one. Where is it? Try matched on fallback here. Output or else. Okay. Where's message handler state? Is that up above? Oh, it is. Okay. Hmm. So we start out unmatched with a signed message. Take message. Output or else. So really it's just, well, somebody's calling take message and then they get a result, okay. Of the signed message, fine. So let's go back to onTell. onTell calls that. Trying to tell. This calls take message, so we get a signed message. Oh. Well, how about that? The signed message has secrets that we don't get access to. Or do we? Are they just not documented? They are pub crate. Okay, so we don't get access to that. So we have to use this function. We cannot... let's change the music. So we have to use this message receiver or the macro. And in the case of on fallback, we do get the dyn any, so we could just use that just to unwrap it. What would that look like? It basically gets nude, gets shoved into the internal state. On fallback, it's called. Get the output, or else we just get that signed message deconstructed and passed to us. So it's basically our way of deconstructing it. Okay. Interesting. Let me check my calendar real quick. So you're passing a closure to on fallback? Yes. Yes. And the idea here, do we let the message handler figure out which function to call, or do we get the any and then call the right function? Yeah, so here, this message is a dyn any. It's nice to have the type figured out for us, but I wonder if there's a way we can do it. Guess what I'm looking? I'm trying to do something very Erlang-ish, and I don't think it's going to work here. I'm looking to call different implementations of the receive function based on the type of message. That's it, really. That's it. Oh, there's a squirrel outside. Huh. Squirrel. Butterfly. Is that even possible in Rust? Could we call a different impl based on the message type? This does seem like this is what enomode's made for in Rust. Or if you knew that the type implemented a given trait, then you just call the trait method. Right. And we're looking to deliver the message and then call some code based on that. I think this is coming back to we need some message to rule them all. I just didn't want prompt, which is kind of long-lived, but it has different stages to understand in each stage all the messages. So ideally, we would have a message receiver for, you know, its welcome stage. Then we would have one for its login stage, just to be able to separate out the logic, but that could be done in a different way. So it looks like message we're going to have a welcome message. Or let's go back to prompt. There might be another way. So in this case, we have a message listener. And the message listener okay, back to where we were. It basically just starts listening for messages for a client. It listens on a particular ID. But we could have different channels, right? Different IDs for different states for the client. So we'd say, hey, we're listening on client welcome. And this is the ID underscore welcome or ID underscore blah. And then we could have different types for each one of those. Yes. All right. I think this will be a challenge for tomorrow. I need to clean up message receiver, get this piece out. Okay, that can stay. Okay. That's good. Oops. All right, code's out there. Let's get it ready going. Oh, you watched this about perfect hash tables? Yeah, okay. That's cool. I definitely want to see that. Cool. Well, thank you. Till next time, y'all. Bye-bye.